this application event and just close this off with a semicolon. And what we should find now, that even if our auction service is down and for whatever reason we decided to restart our search service, then let's see what happens this time. We're still going to fail and we're still going to make these repeating HTTP requests because the auction service is down, but what we do have is our search service running. So now we can click on send and we get our search results back. Even though the auction service is down, we've kind of removed a bit of dependency on that auction service. And of course, if we restart the auction service, then everything just carries on as it was, and the search service will go and make that request, and it will go and get the auctions from the auction service if it needs to. So now we've got a bit of resiliency with our not good practice HTTP service to go and get the data. And like I say, it's not something you typically do in the real world, but we need to do something for this particular service. And like I say, in a real big enterprise level application, you wouldn't be using MongoDB to provide the search. You would be using something different with better technologies to go out and crawl the content that you want to index and put in that database. But this does serve a simple example of how we deal with communication between services in one way, and we won't be using this way again at any point during this course. We'll move on to asynchronous communication, and a bit later on we'll take a look at gRPC, but for the vast majority we're going to be using async communication between our different services. But this brings us to the end of this particular section. So what we'll do is we're going to save our changes into source control, and I'm going to, well, I've just seen a couple of unused imports I can get rid of. We don't want those going into source control if we see them. And let's see, we just want to do a git add followed by a period, and then a git commit with a message of end of section 3 in this case, and we'll just do a git push origin main to finish off and get our changes into source control. And we'll just wrap up this particular section with a summary. Okay, now we've reached the end of section 3, and in this section we looked at creating a search service that we now have, albeit a very simple one of course. We haven't used any proper search technologies to do this. We have used MongoDB for that functionality, and it provides a basic level of search that we will be using just to demonstrate. And please remember, our goal is microservices, not how to create the best search service in the world. And we've taken a look at how we communicate between our two services so that our search service knows about the auctions that are contained in the Postgres database on the auction service side that we now have inside our search service MongoDB. Now, we looked at synchronous communication for this example, and I'm not going to say that that is something you would normally do. It's something that we've done because it provides the functionality that we need and allows us to have data consistency between our auction service and our search service. But there are alternative approaches to communicating between our different services, and asynchronous is one that we'll be using extensively through the rest of the microservices app that we're building. And we're going to take a look at that next. We're going to introduce the service bus into our application with RabbitMQ. Okay, welcome to section 4, and in this section we're going to take a look at asynchronous messaging inside our application. And if we take a look at our architecture diagram, then we're going to focus on the event bus now. Currently what we have is a coupling between our search service and our auction service because we added HTTP communication between our different services so that we could get our databases consistent with each other. That is not normal, and we did that so that we could get our seed data into our Mongo database, and I just wanted to demonstrate a very simple example of synchronous communication. Don't forget what I said. If you find yourself reaching for synchronous communication, then you might want to review what you're doing there and how you're designing your different services, as typically we'd want to go for the asynchronous approach. And in our examples coming up in this section, then let's say, for example, a request comes in, a post request comes into our API auction service, and we create a new auction. Now, instead of our auction service using an HTTP request to our search service, this time we're going to use the publishing approach to publish that message to the service bus, and our search service is going to subscribe to the service bus and receive that message and then take the action to eventually get our Mongo database consistent with our Postgres database. And asynchronous messaging is different, of course, to synchronous messaging, and there's no request response cycle with this one. Our auction service is going to send an event to the service bus, and that's going to be effectively a fire and forget. Our auction service doesn't know about the search service for our purposes right now, and it doesn't know or care if the search service has dealt with that message correctly. It's not its job to worry about that. Its job is to get the message of the created auction onto the service bus, through its exchange and into the queue, and it doesn't care who subscribes to that message either. That's again not its job. So it's a fire and forget approach when it comes to asynchronous messaging. It uses the event model, so it publishes something that has already happened and then somebody subscribes to that thing that happened. In our examples coming up, that's going to be our search service is going to subscribe to something that has happened, for example, an auction being created. And asynchronous messaging is typically used for service-to-service messaging. It uses a transport, one of several different types. There's RabbitMQ, Azure Service Bus, Amazon SQS, etc. But we're going to focus on using RabbitMQ for the very specific reason that we can run this locally on our developer computer. We do not need to be reliant on a cloud service to operate RabbitMQ, and that was one of my goals for this course, is to have everything running locally on our development machines and not being reliant on something like a cloud service such as Azure Service Bus to provide this functionality. Another thing about asynchronous messaging is that services only need to know about the bus. They do not need to know the address of each other. If we were not using HTTP messaging for the search and the auction service, then our search service would not even need to know how to find the auction service. It doesn't care. It only needs to know about the address of the service bus where it can go and pick up those messages from. But it is more complex than synchronous messaging. And that's really because of the fire and forget model that we're going to be using here. Because there are consequences to messages not being delivered, of course, and each one of these messages is something that we'd need to think about. So what if though? What if our event bus went down? Have we introduced a single point of failure into our application by using this model? Well, yes and no. If our event bus has gone down, then for sure our different services can no longer communicate with each other. They will be reliant on the service bus to do that, and if that goes down, then of course a message cannot be sent from service A to service B. But if we design our microservices well enough, then they can still do the jobs that they're designed to do, and they can receive and respond to any requests that come externally to that service. They simply just cannot communicate with each other until this comes back up again. But that's not to say the service bus is not important. It is, and it should be treated like a first-class citizen in our application. It should be given high availability. The message bus should be clustered. It should be fault tolerant, and it should have persistent storage so that should it fail and the new one pops up in its place, then it can grab any messages that are persisted and recover from that failure. And each of our services should implement some kind of retry policy as well, so that if they cannot get to the service bus immediately, then they can get to it at a later point and retrieve any messages that are waiting inside the recovered service bus. So we should aim for smart services that are able to carry out those tasks, and we should aim for a stupid pipe, our bus, that's only responsible for receiving messages and storing them in queues. And this event bus, what we're going to be using for this is RabbitMQ, and we'll talk a little bit more about that next.